So we're given values for x and y, and we want to know how much does the value of this expression exceed the value of this expression when we substitute this in. So some of you use mental math, others will grab a calculator. So I'm going to start first with the calculator. I'm taking 3, and then I'm squaring x, so 3 squared, and I'm subtracting 2 times the value of y, which is 5. So below this, I'm writing 17. I'm coming over here, typing in 2, x is 3, 3 squared, minus 3 times y is 5. And then I go, okay, how much greater is the first one than the second one? We can get that answer by subtracting. Correct answer is 14. What is the greatest common factor of 42, 126, and 210? Let's first start by looking here. Let's first start looking here. If we did not have multiple choice and we were using 2 and 10, I'm thinking of all the numbers that nicely divide into 10. So 1 and 10, 2 and 5. Doing the same thing over here, I have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now the greatest. What's the greatest number in both? So let's see. Do they both have a 10? No. Do they both have a 5? No. Do they both have a 2? Yes, they both also have a 1, but 2 is greater than 1. The greatest common factor in 2 and 24 would, in 10 and 24 would be 2, okay? So how can we quickly do this? Grab your calculator. This is a problem you can do in 5 seconds or less. It says the greatest common factor. So do you think I want to start with the smallest number or the largest number? Okay, you're going to grab it, and I'm going to try 42 into each one of these. So like 42 divided by 42. Okay, it gives me a whole number. It works. 126 divided by 42. It works. 210 divided by 42. It works. That's my. Now what happened if one of those didn't work? We'd cross out option J and we move on to option I, and we keep going down the list until we find the largest. There's a couple terms here that make this kind of complicated. First is prime numbers. Remember, the only way to get a prime number is taking that number times itself. So like 3 is prime because we can go 3 times 1, and that's the only combination. Also know that 1 is never prime. So this uses the word from, not between, but from. So I want to go from 1 all the way to 13, and I want to include it. The only way to get 1 is 1 times 1, but I've just said 1 isn't prime. It doesn't count. The only way to get 2 is 1 times 2. It's prime. 3, 1 times 3. 4 doesn't work. 5, 1 times 5. 6 does not work. 7, 1 times 7. 8 does not work. Don't assume that all odds are prime, because 9 is 3 times 3. 10 does not work because it's even. 11 is 1 times 11. 12 is even, doesn't work. 13 is 1 times 13. 1, 2, 3, 4, 5, 6. Correct answer is C. Common mistake is students also think that 1 is prime. It never is. Remember, from means we also. How many multiples of 3 exist between 3 and 42? Okay, so multiples is one key term. Between is the other. Between means I do not include 3. I do not include 42. It has to be between them. So multiples of 3. 3, 6, 9. Is there a fast way of doing this, Mr. Stork? Absolutely. Everybody go 3 plus 3. If you do something twice on your calculator, remember, is it? Go plus 3 again. So I know 6 is the first multiple I'm considering. Why am I not considering 3? Because it's outside. It needs to be in between. So there's number 1. Number 2. Now watch. I just hit enter. 3, 4, 5, 6, 7, 8. Hold on. 9, 10, 11, 12. Do I consider this? Did I consider this to be 13? No, because it has to be in between. So 12 is the correct answer. How many irrational numbers are between 2 and 9? So between, not including 2, not including 9. Now, what the heck is an irrational number? An irrational number is a number that's a decimal, that's ongoing, that has no pattern to it. So like 3.123, 123, 123. Okay, I can predict the next number. That's rational. But when you have something like pi, or something like 4.169283684, right? You don't know the next number. It's irrational. So between anything past 2 and before 9, there's an unlimited number that could be decimals that have no true pattern to them in which you can guess the next number. There's an unlimited number. So there is a couple key terms in order to take this math sentence and put it into an inequality statement. First is, we see the word 3, but here's it. I want you to go here and I want you to put a little arrow above the word that. Whenever you see the words that or from, we have to flip the order. So less than means subtract. What do you mean by flip the order? Well, 3 came in front of it, but now it goes in back. Twice number came behind, but now it goes in front. Greater than is like this, and 5. Correct answer. Okay, so I know I'm working with a rectangle. If they don't provide a picture and you're able to model what is being said, you're probably going to have a better understanding of it. So it says we know the length of a rectangle with an area of 54 square centimeters is 9. So this is my length, it's 9. I don't know what the width is, and I know this is 9. And we want to come up with what is the perimeter. So I know, make sure you're watching, Eddie. So I know that to figure out this distance, I know I could revert to area. So length times width, is 54. I'm going to call these x's. 9 times some length is equal to 54. Divide by 9, x equals 6. So when I first did this, I was like, oh, the answer is 6. But then I had to go back and go, but what is the perimeter? Okay, 9 plus 6 is 15. 9 plus 6 is 15. 15 and 15. If over the course of a semester a student has the following scores on given units, what is the minimum? What is the lowest percentage they need to receive in the final exam in order to receive at least an 81% average? So please make, in this case, 1, 2, 3, 4, 5, make 5 spaces for the 5 that we know. We're going to put those into each one here. And 1 for the missing piece. And how do we figure out the average? Well, we add them together. And then we divide by how many we have. 1, 2, 3, 4, 5, 6. Although we don't know that last final exam. And we know we want the average to be at least 81. So we want to know what's the smallest this could be, and we still get 81. So let's put this as an x, if I want to solve for x. So if I want to solve for x, I have a numerator and denominator. So first I'm going to get 6 out of the way. So opposite of dividing is multiplying. So I take my calculator, and I take 81 times 6. 486. 46 equals this numerator. Now, to get x by itself, I'm going to add these up, and then I'm going to subtract them to the other side. So I already have this on the right. I want to subtract all those other numbers. 85 plus 65 plus 88 plus 80 plus 76. There's the answer, 93.